All right, do we have everything going the way it should? All right. Is this all working the way it should today? And can everybody hear me? All right, sorry guys. I don't have Stream Elements loaded on OBS because I had to do some rework on OBS from the last update. So I have my chat open up on a different laptop because I can't run two laptop or the one same laptop at the same time. So you guys will just have to kind of bear with me as I try to answer the questions at hand here. This is a Crossfire 8K. Hey, Sumia, hey, welcome. Thank you guys for dropping in. Looks good, man. Yep. Hey, thanks. You know me. I'm always struggling with videos, cameras, whatnot. So I've gotten away from the one camera that's given me a complete headache, and I've gone to my Samsung. Uh, what is this thing? The S21 Ultra or whatever phone this is. So yeah. So of course, as usual, still working on equipment. But when you do amplifier repair as a business, you just don't have a lot of time for really anything else. This does take up a tremendous amount of time to repair amplifiers for a living. So, I do thank you guys for watching and subscribing to the channel and dropping by and asking any questions. So, I just wanted to go live with you guys today because for this one camera, it's been kind of hard to record videos, so I figured I'd just go live and try to answer questions as people drop in and notice that I'm on and live today. But I have been working on this Crossfire 8K for about, I think this is day 4. I think I've been working on this amp. The first day and a half was power supply rebuilding, and then the next 2 days I've spent on this output board. Sumya, hey, just to let you know, oh, I'm not quite sure how to pronounce your name, but you are the website designer, correct? Okay, so I have the auxiliary power supplies running this board right now. As you can see here, I've got my plus minus, well, my power supplies are set at 14.5 volts right now. So um, I do have the plus minus 15 volts, and I have our negative 12 volt referenced to negative rail over here. So I'm just running a test on this board. I've just got it together. I have found all the problems, and there was multiple problems with this board. It burned up really bad. So it's kind of a domino effect. You find one problem, you fix it, you fire the board up, you find another problem. But overall, this board is about 80% rebuilt when it comes to the SMD components. And I do have just a couple minor trace repairs that I got to do on this side. Yes. Oh yeah. So for anyone looking for website design, I do recommend, let's see here. I'm not really good at this whole chat box thing or linking people, but what I would do is I would recommend getting a hold of this person here for any website design. All right, sorry. Again, I have to deal with two different computers right now. Okay. But yeah, I'm just running a test on this. This scope is fired up. This board is actually running. It's running at 15 volts. So I'm just keeping an eye on the output sine wave. I have a 50 hertz signal going in, 51 hertz. So I have 51 hertz here at the output at 7 volts. So about 14 volts peak to peak, which is correct because I am about 14.5 volts on the rails. 14.5 volts. Oh, I got to be careful. Someone had mentioned that my wires were in the way when I was probing. But I always probe gate source. Always, 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 always. I may probe source drain every now and then, but I will always probe gate to source. Always. So if you see me probing around on a board through 30 different transistors, I'm gate to source. But what I'm doing is, believe it or not, this 15 volts applied to this board. And again, this is running. If I had a little speaker, I could hook it up right here at the output inductor and ground, and you would hear my input tone. This thing is actually up and running right now. And at 15 volts, you will feel the transistors heat up. If you have any sort of drive problem, and it could be the smallest problem, and they will start to not heat up extensively hot, but they will get warm at 15 volts. And these, again, are 10 amp power supplies. So they will warm up. And I can usually tell just by the feel if I have a bank that's not running right. So when I found all the problems on this board, I replaced almost everything on this card, almost. When this failed, it took everything out. It took out the muting circuit. It took out the protection circuit, the output part of this card. It just destroyed a whole bunch of stuff. So this morning I finally got everything running. I got it to where I saw low side drive. As I've always mentioned, you're going to find low side drive. This has got 4 ICs in it, so you're going to have 4 separate sections. So your low side drive is usually in the middle. So I had low side drive on all 4 sections of this amplifier. But when I loaded the transistors up and I had high side charging, it was not running right. Well, let me catch up with this chat here. Got to swing between 2 different computers. But come to find out, I had missed a pin on each of these IRS 21844s, and it was the high side input voltage pin is what I missed. I didn't miss the solder, but it wasn't quite soldered in place. So I went and resoldered and reflowed those 2 outside ICs, and then I had proper switching here again, because I could tell they were starting to get a little warm, so I knew my switching was off, and sure enough on the scope it showed that. Hi Delance, thanks for joining in today. just going over just really just questions. If anyone's got questions to ask, feel free to ask questions. I'm more than happy to answer questions. But just as I was going through this amp today, I just wanted to get a good old live stream fired up for you guys. Just to let everyone know I'm still alive. I'm still kicking. But extremely busy. So let's see here. Do we have let's see if I can fire up the scope here without making too much lag in the video for you guys. Rigol USB based search. There it is. DS1000Z. Man select. Oh, I don't have the scope set up for yeah, unfortunately my scope is not set up for yeah, I don't have, sorry guys, I don't have the scope set up for my Droid Cam for my cell phone that I'm using. Another fail. Hello, the best. Hey, how's it going? Did you I know I fixed an amp for you. Did you get it back yet? So I wanted to show you guys, but I'm just having a heck of a time. Hmm. Well, yeah, I will eventually one day get that scope up for you guys. Sorry about that. All right, so back what I was doing. I was just making sure that this board is good to go, that there's no issues with the board itself. And of course not. Like I said, I had found the two problems in the drive itself for the high side on these two banks here, which was my two outside ICs that I had missed. All right, so like I had mentioned in the previous video, you can use a low voltage supply to test these boards before putting full rail voltage across these. These are the 24N40s, which can become a little hard to find. And just think, this is an 8K and it uses 32 of these 24N40s on the output section. So you can kind of get an idea why you would want to find a solution to testing these without having to use the high voltage in case one goes south on you and you don't happen to have a matching one to replace the parallel bank. So I absolutely love this method of testing before applying full rail voltage. It really does save a lot of stress and headaches when it comes to sliding these boards back together and firing up the amp for the first time with full rail voltage. Because if I can find all the problems using 15 volts first before I'm using 200 volts, then the chances of survival for these transistors is greatly increased. But since I'm not feeling any heat anymore on those banks, and I do have my 50 hertz signal, which you guys can't see unfortunately because I don't have this camera set up with the scope on it. I will add that to my to-do list. And I have the 50 hertz coming from both sides. If you look at the smaller inductors here, you'll see that there's two in parallel for each side. So there's two halves to this board, but there's really 4 amplifiers. So I just want to make sure that I have my 50 hertz at each half of the board. And you can't check past here because the relays aren't on because we're not hooked up to the power supply. So but what I look for is I look for frequency, switching frequency, which if I take off the input, I will lose the modulation at the output, so it'll give me a square wave. And we're 10 kilohertz on the low side drive. And 28.4 kilohertz on the high side. 28.4 and 28.4. So as long as my frequency is the same, 28.4. Oh, did you guys see where I was probing? The gate. 28.4. And what did I say the low side drive was? 28.1. Hold on. 28.1. There we go. 28.4. I'm blind. I gave you guys the wrong frequency at first there on the low side drive. So 28.1. 28.1. 28.1. 28.1. 28.1. So the driving frequency is the same. My amplitude's the same on the drive. My frequency is the same. So I do not suspect that I would have any issues giving this board full rail voltage. No transistors are heating up on the switching. Now, I wouldn't be feeling it like this if we were at rail voltage levels, guys. Just to let you know. This is at 15 volts, 14.5, so there's nothing here that's going to jump out at me. But if if you have this hooked up to the power supply and you're at rail voltage, don't be running your fingers across the back of these transistors. That's all I gotta say. That will give you a bad day. But these are 200 volt rail capacitors, so I'm probably suspecting 160, 172, 160 to 175 volts on the rails, which is pretty significant if you think about it when it comes to DC voltage. So I'm going to go ahead and turn off my power supplies and disassemble my wiring. I used two, I don't know if you guys have seen or not, but I did release a video. I used two of these overseas switch mode power supplies that are wired up in, what is that, in series to give me the plus minus 15 volts. They're modified power supplies. So I can adjust them from 9 volts to 15 volts, I think. And eventually you just get to a point where you can get this all hooked up in just a matter of minutes to use low voltage for testing. I don't know if you guys can see this board has just been through a just a nightmare of a time. You can see right over here in the upper right hand or upper left hand corner, I've seen this on several boards where the negative terminal of the speakers, this will literally burn up and melt right here. I've seen this on a couple Crossfires now where that side is burnt up. When you have a short, you know, I don't know if people really realize the amount of current and voltage that's behind these when they short out. Just a massive amount. Yeah, just a massive amount of voltage and current. You really got to respect amplifiers if you're working on them. That's for sure. But I'm just firing up my Hacko, my FR301. To, of course, desolder my wires. And you can see this wire I had to add all the way along the side going to the input pin of my 12 volt regulators, because even on sundown I've had to do a couple sundown amplifiers where it takes that trace that follows along that edge right here and it burns it up in 20 different places. So what I do is I just take a wire and I run it, and I try to follow the gate path just right off to the side. I don't want to create too much inductance on that line, but I just take a wire and I go from here to here to get it back to the auxiliary power supply windings. There it is. There's the bottom side of the board. This output board, even though it was severely damaged, wasn't burn up near as bad as the power supply board. Power supply board is cooked pretty bad. But overall, this board turned out quite well. It's given me a couple of headaches the last couple days, but I've got them all figured out. And all I got to do is just get the boards back in the heat sink and fire it up. With a 1 ohm load on it. I test at 1 ohm. I don't do any half ohm testing. I don't do any quarter ohm testing. And even if someone were to ask me to test under recommended impedances, I will tell them that they probably would have to find someone else to do that, because I don't overload amplifier boards. All right, there it is. Output section is finally done. It's taken a couple days, but I finally got this output section back together. El Hugo, hey, thanks for dropping in. Sorry, as I go in between my bench and my laptop here. From the Pacific Northwest, yes, I've got old school class AB amps to send your way soon. Oh, I thought I recognized your name. Oh yeah, send them on in. I've got several large amplifiers that are in for repair. That is gonna kind of bog me down just a little bit. I've got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 of the substantially large amplifiers that are kind of in line. So I'm about 2 weeks on just those. But still, about 4 to 6 weeks turnaround time right now. This amplifier here is cutting it close, so I'm probably going to be closer to the 6 week on this. This one here was a challenge. So that's the output section. And this is the power supply section of that Crossfire 8K. So I'm just going to do a quick review of this, because this amplifier will be going back together today if I don't run out of time. What time is it? 3 o'clock? All right. But yeah, that's my goal, is to get this amplifier back together. And hopefully tomorrow, which will be 9/27, I will be testing this. Got to kind of tip these transistors back just a hair to slide it back into the heatsink. Yeah, this power supply, it was something else. Got a couple holes that got burnt right through the driver area. And just to let you guys know too, I am working on some DIY PCB boards that will kind of more or less fit right in this spot here for when these burn up and you completely burn out the PCB right here. I'm trying to work on a solution to keep these amplifiers alive and well and out of the ground by making little replacement sections for the drivers. But this is looking great. All the drivers are solid. Except for my flux. Gotta clean up my flux a little bit there. But looking good. I think this is good to go back together. So are any of you guys working on any amplifiers today? Let me know. Let me know what you're working on. Got any questions? I'm here to answer any questions for you guys too. I'm just working on these Korean boards here. I got a couple 16Ks that I got to get done. Got a Salt 12 I got to get done. I got a DC 5K, smaller board, and those are a little smaller to do, but there's still just a pile of transistors you got to remove and replace, and all the drivers and all the gate resistors. So I already know what's coming up. You start to do so many of these, you already know what's wrong with them. And cleanliness. I'm very meticulous with my work. And then it still kind of baffles me when people will hook up their amplifier, and for some reason some people, you know, they just will hook it up or do something incorrectly, and then the amplifier won't work. Well, then they turn around and email me saying, hey, my repair doesn't work. Okay, well, I guarantee you that it worked when it left. So now, if I wasn't so meticulous with what I do, I could probably understand and see if I had a lot of failure rates, but I do not have a high failure rate. There it is, ready to slide back into the heatsink. And I've tested this power supply many times. This is probably got, it's probably got a couple hours worth of testing on it, because it took a hit. But everything's good to go on this. So I do believe this 8K is ready to go back together. Well, let's put this 8K aside. I did have a Taramps show up that we will go ahead and diagnose real quick here before I end this. I had gotten some comments that had stated that I get a lot of Taramps in for repair. Well, I mean, you know, when you work for somebody, you would kind of expect to get a lot of, not a lot, I mean, you know, you'll see it a lot. I don't get a lot of Taramp boards in. They come in steady. I get them pretty steady throughout the year, but I don't get a lot of Taramps boards. A lot of these Taramps failures are contributed to installation or vibration damage. So this is 1 of 21. 1 of 21. This is out of warranty. So right off the bat, I can tell you this is going to be a private repair. Never been opened. And this was sent to me with no information. I barely even have a name. Nothing in the box. I mean, all I can say is it came out of California. So hopefully whoever owns this particular base 3K that just sent it in. Hopefully they can send me an email with their information, because this is a private repair. And they did not fill out a repair request. So this is kind of, you know, just how it goes. I will get amps in that I have no idea whose it is. Don't know what it's doing. I mean, it's obvious I can figure out what it's doing. It's Taramps. But you know, it doesn't help me when people don't send their information with the amplifier. But that's okay. It'll sit here and until either someone contacts me, or 90 days from now I will mail it back to the address it came from. $10K, 8.8, $10K, 8.8. Oh, this isn't looking good already. $1K, 1K, 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 and 1K. And why do you see 1K? It's because you're reading that pull down resistor. 1K pull down resistor. So why or what is this doing or not doing? Let's find out. Oh my. No screw in that RCA. Nice, nice. All potentiometers are turned down. You were nice enough to leave me some copper wire sticking out of the remote. Maybe. Well, blue light. Blue light means go. Oh, my probe is not grounded properly now. Fan is sounding a little rough, pretty typical for a Taramps. Gate drive on the power supply is perfection. Drive looks perfect. So why is this here? Good question. Let's check the DC offset on this. 0.027. It could be a little lower, but it's not up in the, you know, in the single volt digits there. So well, I guess it's running. Take our 50 hertz signal. Give it an input. Adjust my scope. Look at that. There's a sine wave, 50 hertz sine wave. Well, there it is. 51.5 hertz. Other side, 51.5 hertz. Yep, amplifier works. So just a fine example of an amplifier that gets sent in and I have no background information on what it's doing. Of course, from here it goes to the load bench, and then I just play music through it. through the 5 1/4, just to listen for any high-pitched noises, and then it goes to the 12-inch, listen for any low-frequency noises, and call it good from there. Sometimes I guess the dials can be noisy, but initial inspection tells me that there's nothing wrong with this amplifier. So minimum service charge, $40 for any amplifier that comes into Ellensburg Amplifier Repair and Service. Just to let you guys know, if you send me an amp and I replace a single part in it, my minimums are $40. Now, if I get an amp in and I don't do anything to it and it works, then I probably won't bill you for it. But if I get you to a point where I have to get you on load bench to listen for any noises or anything like that, then I will charge you the minimum. Because it's not cheap to run these power supplies to power up all these amplifiers that I do. So, yep. Don't know what to say about this one. But hey, guys, I do thank you all for watching. I just wanted to jump on live with you guys, see any issues that I needed to iron out. Obviously, I have to figure out my scope image here, but you know, the things in life that has to keep us on track. So I do thank you guys for watching. If you like this kind of content, please like and subscribe. Leave your comments down below. And I will, of course, answer any questions that pop up the best I can for you. I will help you out the best I can. And if you have any amplifiers that need repair, please feel free to contact me, ellensburgamplifier.com. And we'll go from there. Thanks for watching, guys. I'm going to slap this 8K back together so I can get it ready for testing tomorrow, and we will move on from there. Thanks for watching, guys. Keep your fingers out of the rails. Stay safe. Catch you on the next one.